Okay. Um, so the, huh, why is that missing here? That's very strange. Okay, well, whatever. This is the general format for a SQL query. Select followed by, and I'll remind you that this select is a SQL select, not a relational algebra select. They use the same word, but for two different operations. This select behaves like a projection. So these are the columns of which you want returned in the relation. From, this works like cross multiplication, and the where is the equivalent of the relational algebra select. So after the where, you put your predicate, and that is the filter that you're applying to the relation that you're referencing in this from section. So here, projecting name and selecting age greater than 48 of relation S1 is captured simply this way. So here we want the name for the projection. From, we're doing this operation on relation S1. And the predicate that we're applying to this relation is age greater than 48. Now, there's a few things that I'm going to be enforcing in this class that is just good practice, really. So the select doesn't work exactly like the project, because the project in relational algebra works on like sets. There won't be any repeats. SQL can actually allow returning repeated values, but the select distinct, this will return no repeats. And this is what you should default to, unless you have a reason not to. If you have a reason not, or if you have a reason that you want repeats, then you don't need distinct. But, okay. The other thing is to rename your tables. This helps. This doesn't have any effect on the outcome of the query, but one, it can help saving typing time, because if the table names are really long, then you can reference them with, for example, a single letter. Oftentimes, relations in the real world aren't named very well, or maybe they're misnamed, but legacy reasons, they keep the table that name. So you can rename it something that is sane. And then also, queries in SQL can also get quite long. And so it can be helpful for the human writing the query, you, to rename tables so that you don't get confused when you're dealing with lots of different tables. So rename your tables, and then you will reference those particular tables attributes by whatever the name of the relation is, dot. And then the last thing is, don't use the star, especially in production code. If you're debugging, that's one thing. You can be a little more lax and stuff, but if you use the star, which just finds anything, for example, I did this, select distinct star, that's a wildcard character that will return all of the the columns of whatever the relation is. The problem with this is that it can cause some nasty, hard to track down bugs in production. There's different teams of people who are working. Probably the people who are going to be writing the SQL queries are not going to be writing the web front end or the web API or whatever. These are generally going to be split, and there's not always the best communication among teams. So things can change in the database with one team who decides internally to make a change in a database, and then there can be other parts or other groups in the company that I mean, everybody's just trying to be lazy and take the shortest path, basically. So don't use this in production. Actually write everything explicitly that you want. Takes a little bit more time, but it will avoid some nasty bugs. Okay. Right. So there are 7 basic operations in relational algebra. There's the union, the set difference, the intersection, cross multiplication, projection, rename, and select. We've already talked about the projection. That's this. From is the cross multiplication. Where is the select. And so we're just going to be talking about how to do the other ones. First one is if you just want the cross multiplication, then you can select 2 relations to cross multiply, return all of the columns of that. So here R has 3 attributes in that relation, S has 4 attributes, and so the result of their cross multiplication will be 7 attributes, and we want to return all of them. Because we're not doing any select here, you can write, this is my personal preference. I'm not enforcing this. You can do it whatever way you want, but for me, I like sticking to the select from where pattern. So here, the where actually isn't even needed because there is no select operation here. So you could write this without the where, and by default, it will do this, where true. I like to do this personally, just that way. If I'm reading my own code, or if somebody else is reading a query that I wrote, they know that, or I myself know that I didn't forget something. Oh, sorry. If there is no where, maybe, maybe somebody would think that, I don't know, did it get deleted? Where did it go? What was this person actually trying to do? And it's fine, it'll work, but that's why I prefer to use this. It's my own personal preference for this. I'm not enforcing it, just explaining why I'm doing that. Now, the natural join is identical here to the cross multiplication, except we are applying a select statement. In particular, we want only those entries in the relation where an SID in table R also appears in table S. So yeah, other than that, it's the same. So we can do our natural join. Of course, you'll remember the natural join can be realized with a cross multiplication, a select, and a project. So nothing surprising here. Okay. So we'll just go through more of these queries. Oh, well, no, I'll get to that in a minute. Okay. How about a union? Let's do this real quick. So for example, this. How would we realize this in SQL? Well, it's pretty straightforward. We have two relations that we're concerned with, and then we want to take these two relations and compute their union. So here, these are the R's. So this is this part of the query. So we want to, I'm sorry, except we just want the SID. So we're just returning the SID from relation R. So straightforward. That's this first part. The second part of the query, this part, is also pretty straightforward. Again, we're projecting the SID here, except we're dealing with table S1 instead of R. And here we have a predicate, so where the age is greater than 46. Okay, so this top part is the left part of the query, this bottom query is the right part of the query, and the union is just called union. So that's pretty straightforward. Great. Can I explain the where true part? So again, this is the sort of standard format for a SQL query. You have select, from, and where. Here, the where is optional. Oftentimes you'll use it, but strictly speaking, it is an optional parameter. You don't have to have it. Now, so you can just write a query like this. In fact, this would be the same thing, right? This query where I delete the where true is no different than if you include the where true. This is my own personal preference to emphasize for myself and maybe for other people reading this that I explicitly do want everything returned. If I don't include this, then I'm implicitly saying that I want everything returned. But just for my own personal tastes, I like making that explicit. They'll have the same result. You can write it however you like. This is my own personal preference. Does that explain it, Hassan? Yeah.
Professor,
Yeah.
could you explain the union in the SQL section? I've never seen a union in SQL. Does that actually an actual function?
Yeah.
Oh, okay. All right,
Hmm.
thank you.
Sure. Okay. So the next one is also going to be similar. I mean, really, there's not a whole lot to say about this. Let me go up here. Instead of the union, if we wanted to do an intersection, it's pretty straightforward. Instead of union, intersect. Okay, so pretty straightforward. Like I said, mainly it's just learning some syntax. Now, the last one for the query, anyway, would be a set difference. This. The set difference. Now, here, the set difference SQL language uses the word except. So we want everything here except for these things. Now, note, except is not supported in MySQL. Let me say this really quick. Okay, so SQL is an old language from like the 70s, and for the most part, it hasn't really changed. So SQL is a sort of a general language, and then there's different programs, different companies that have implemented the SQL language and added some stuff to make things easier. For example, this except. This is supported in Postgres. PostgreSQL. Just shorten it to Postgres. So, sorry. Oh no, did I just close that? What happened? Sorry about that. Okay, there we go. So Postgres, which is what I would recommend for this project, it just has an expanded vocabulary. When earlier I was teaching you guys about the primitives in relational algebra, that is intersection, union, set difference, rename, select, project, and what am I forgetting? Anyway, these primitives. And I said, for example, the join is not a primitive. You can do the same thing as a join using these other operations, like what we've seen earlier today with that join. The set difference is also not necessarily a primitive. You can realize a set difference using the other operations. So if you're using MySQL, then you have to make this a longer query because MySQL doesn't support this set difference. Postgres does, along with some other useful kinds of nice things. So if for some reason you are particularly interested in MySQL, like, I don't know, there's a company that you're interested in and you know that that's what they're using, and therefore you want to use it on your project, let me know, because I can go into this kind of detail. But for everybody else, I'll just leave it like this. Used Postgres, and that makes the set difference just a one-line thing, except the same as an intersect or a union. Okay. Yeah, I think that's basically it. We have our project, we have the cross multiplication, we have the select. Of course, we can do joins. We have the union, intersection, set difference. The rename is implicit here. So I can, for example, here, I don't have to rename the SID from table S1 as, for example, SID2, because that's done implicitly. So this SID can already be referenced by s.sid, which makes it different than the r.sid. So this is, the rename is sort of an implicit thing in SQL. It's done in the background. Okay. So there's a few more things that we have to talk about with SQL, but as far as these, are there any questions about any of these? Okay. Then let's see. Okay. So here is a sort of whatever generic SQL statement. And I want to talk here. So this is where your predicates go. Like the select has a predicate. That's what this where statement is it's just the select. The relational algebra select. So what are the supported parts of a predicate in SQL? Again, like, so this is not totally comprehensive because it also sort of depends. I mean, if you're using a different flavor of SQL program, they might offer more, but these are widely supported. You have and or. So those are, what's the word for that? Whatever. Yeah, you can say you want this to be true and something else to be true, or something else to be true, etc. You can say not something. Let's see. There is also greater than or equal to, less than or equal to. For not equal, you can say not equal, like this. Oh yeah, by the way, I should also mention this, I guess. I push these down. The equal is just a one equal sign. Okay, so you could say where, in fact, we already did this, SID equals R.SID. For example, you do not need to use this double equality thing because in Python, as you might be aware, this is different than this. This is setting the variable a equal to the value of 1. This is a check, a true or false, to see if the variable a is equal to 1, then this second statement will return true. It will evaluate to true. If a is some other value, then that will evaluate to false. But in SQL, because this is a predicate, you're never going to be setting a value. So here it's just a single equal sign. All right. For not equal, you can say not, and then the things that you're testing equality for, and you want that not to be true. There's another one, which is this. Sorry, so that's 2 angle brackets. This is also not equal. So you could say, s.sid not equal to r.sid. Or you could do this, not. Whichever you prefer. So it's not a dollar sign, it's an S. So you can say that you want something to be not equal this way, or you can do it this way. All right. You also have basic algebraic operators. Here, these are algebraic, so with numbers. That is, you can add, you can subtract, you can multiply, and you can divide. So you could say, I don't know, where s.age times 6 is less than, I don't know, whatever, just making it up, r.age divided by 4. You could write something like that. So this star here is a multiplication between integers, and this division here is also a division between integers or numbers. Real numbers, integers, whatever. Okay. What else? There's a couple more. I think. What am I missing here? Yeah, then you have true and false. True, false. So I can say where true, for example. Okay, so those are things that you can do in order to create the predicate in the where. And yeah, very good. All right. Okay. So there's 2 more things that I want to talk about. The first is something called a nested query. So far, everything that we've talked about, all of this, I think pretty much covers it for SQL. Then there's there's a few aggregation operations and these so-called nested queries. And I'll give an example of the aggregations as a nested query, because I don't know how else you would do it. But first, let me talk about what a nested query is. So, go. Nested query. I think everybody who's in this course has taken Python or some programming language. And in languages like C or Python or Java or whatever, you have loops, and you can have nested loops. So, for example, a simple clock operation. Okay, like I want to write a program that will print out all of the times that can exist between 12 and 11:59. And I just want to print out a list of these. I'll just print them out to the console. And I'm not going to worry too much about the formatting. One way I could do that is with this over here, nested query. This is a nested loop. So a nested loop, you have a loop inside of a loop. So I could say, for example, for hour in range 1 to 13, for minute in range 0 to 60, print hour plus a colon plus minute. Right. So this is an example of a nested for loop. Let me turn this off. Sorry. There we go. So what this would do is first, first it would set hour equal to 1, and then it would set minute equal to 0. So while hour is 1, it's going to run this whole thing. So first this will print 1, 0. Then the inner loop continues. And so the next thing it will print is 1, 1, then 1 colon 2, 1 colon 3, and on until 159. Okay, that's the first iteration of this loop. I'm sorry, it's one iteration of the outer loop and an entire iteration over the inner loop. After this inner loop finishes, then the outer loop ticks up. And so now it would print, now hour would be equal to 2. And then the inner loop starts fresh. So this would print 2, 0, 2, 1, all the way to 259. And this would just keep going until finally the hour is 12 and it prints 12:59. So this outer loop here is going to be responsible for increasing the hours here. And this inner loop here is going to be the minutes. And every time all of the minutes are displayed, that for loop stops, and then it goes on to, then this inner loop gets repeated again. So this inner loop is actually running 12 different times, each time going in 60. Okay, are there any questions about this part? I mean, I think that these are things that you would have already learned, but yeah. All right, fine. Then how does this relate to SQL? Well, in this where, you can embed another SQL statement. Okay, so this is why it is called a nested query, because here, well, first of all, there's two queries, and this one gets evaluated first, this one on the inside. Similar-ish to the way that nested loops work. Here, first, this inner query would be executed and return some relation. And then this predicate is applied to this relation. Okay? Let's see an example of this. Example. Question? Okay, so given these relations, reserves, and that has an SID column, a boat ID column, and a day column, and a sailor's relation with column SID, sailor name, rating, and age. So these are the relations that are given to you. And the question is, find the name of sailors who reserved boat with ID 103. Let's see. Yeah, I'd like to ask somebody here to do this. You can actually do this without nested queries. You can do this in a standard way. This is a fairly, hopefully, easy query. Let me pick on, I don't know, how about Jacob? Jacob, do you have a mic? Okay. How about Karnik?
Hey, how's it going?
Yeah, that's all right. Yeah. So how would you write this SQL query?
So you'd start off by selecting the sorry, give me 1 second. You start off by selecting the SID, like the distinct SIDs.
Okay. Well, we want names. So sorry.
Well, okay, so I guess you'll start off from the from section.
Yeah, sure.
So yeah, and then you can from there you can rename the tables. So sailors as S and reserves as R.
Okay.
And then you'd select find the name of sailors who. So you'd select the S.S name.
Okay.
S.SID and R.SID.
Like this?
Yeah. And where would be R.SID is equal to 103?
Okay. It's missing. So in some places it's has too much. That I'll just get rid of this. You don't need to return the SIDs. This is just find the names of the sailors. So we
Okay.
just want their names. So we can get rid of that.
Gotcha.
There's something else missing. I'll tell you it's from the where.
From where? Yes.
Mm-hmm.
Who with ID? Oh, wait, boat is boat ID?
Oh, sorry. That's the ID.
I'm not sure, to be honest. What else is missing?
Right. So we want it to be like a join. We want if we only want to return the sailors who, if they have an SID, it's the same SID in table sailors and in table reserves.
Oh, okay. So would it be R.SID is equal to S.SID?
Yeah. And R.SID is equal to S.SID. Yeah. Yeah. So we're doing basically a join and making sure that in addition to that, we're only returning this particular boat ID. Great.
Got it.
Okay. Very good. So this is one way that you can do it, and it's fine. It works. No problem. There's another way you can do it, and I'll just write this. By the way, this as you can have it or not. You can also just say from sailors S, whatever you prefer. S.SID in. Oh, I'm sorry, I forgot that. This is in or something in. Okay. So this is another way of doing it. That formatted a little bit better. Okay. So first, the inner query gets run. And so this will return all of the SIDs from table R where the boat ID is equal to 103. Now, from that relation, which is just going to be a list of SIDs, we want the SIDs where the S.SID appears inside of this relation of the SIDs from table R. And we want to return the names that are associated with those SIDs in table S. I'll say it again. This inner query gets run first, and this will return a relation with R.SID, and it'll have some numbers of whatever their sailor IDs are. I don't know, 42, 86, 23. So these are the sailors who, or these are the IDs of the sailors who reserved boat ID 103. That's this first part. Something like what it would return. I'm making up the numbers, but whatever. And now you have some other table S, and this has SID, S name, and other stuff we don't care about. So 42, 86, 16, 23, I don't know, John, Paul, Peter, Susie. Okay, so what this outer one is doing is it's saying return the names of when an ID here is in this list. So here, 42 is in the list, so include John in the result, the name of that sailor. 86 is also in the list, so return the name Paul. These two sailors don't exist in this R table. Maybe they never rented boat 103, whatever. Maybe 23, that's a sailor who rented the boat, but he just doesn't exist in table S. So that won't be returned. And so the result, the final result, will be S.S name with John and Paul. This would return the same result, by the way. I mean, these are equivalent in their result. Okay. Questions about this? Why wasn't 23 included? So 23 is not included because here, this is the predicate. We're returning those rows such that this SID from table S is in this. 23, oh, I'm sorry. Yes, you're right. I shouldn't have written 23. I didn't mean to. You are correct. I meant to write something different, to emphasize that there might be one that's missing. Sorry about that. Yeah, I meant to make that different, not 23. Okay, good catch. Okay, so why would you think of doing this? Why? What's the point? I mean, the queries, they both give you the same result. In fact, the first one, it's shorter to type. So what's the point of doing this nested query? Besides the fact that you can. I mean, of course you can. So, but there's a better reason than that. Can anybody think of it? The question is, why might somebody prefer this way? Any ideas? Okay, let me pick on somebody. I don't know, maybe you guys actually know, you're just quiet. How about Alan? Do you have a mic? Alan, do you have a mic? You there? Okay. Mic hasn't been working. Okay, no problem. Well, do you have any ideas? Or you can just say, I don't know as well. Not sure. Okay, great. How about Ali or Ali? No Ali or Ali. Okay, how about Arbaz? Do you have a mic?
I'm not sure either.
You're not sure either. No problem. Hold on, but I'll stick with you just because you have a mic.
Okay.
What is this doing?
It is creating like a, what's the word I'm looking for? I guess it's just restricting you from that certain table.
Restricting you from that table. This is doing a
to that
cross
table.
multiplication. Let me get rid of this stuff. Do you remember how cross multiplication works?
Yeah, it selects the similar attributes.
Yep. Okay. So
Yeah.
yeah. So what would the columns of this table be? I'll go up here so you can see these here and here.
So you're cross multiplying. I'm not sure.
Okay. So the columns are going to be all of the columns from each of the tables. So you'll have these from table R. And then you'll also have these from table S, s.sid, s.sname, s.rating, and s.age. So those are the columns. This is going to be table R times S. That's what this is doing, this cross multiplication here. This thing here. Oh, sorry. So this is going to result in a table, in this case, with 7 columns. And here, if I have a table R, I don't know, just to make it easy, in a table S, what does the table R times S look like? Let me do this. I don't know. Name, age. This is table S, this is table R. So this will have 2 columns, name and age. I guess s.age, r.name. What are the rows of this table? Like what's the first row?
Would it be like A1, A2, A3?
Yep, A1, A2, A3. Yep.
And then B1, B2, B3.
B1, B2, B3. Yeah. So exactly. So that's a cross multiplication. And you'll notice here in this blue table, there is no cross multiplication. So here, Arbaz, I'll ask you this one last question and then you can go. Let's say
No worries.
if the size of R is 1,000 and
Yeah.
if the size of S is 1,000, like each of these independently, table R has 1,000 rows, table S has 1,000 rows. How many rows are going to be in R times S?
10 to the 6th power.
Yep, 10 to the 6th. 10 to the 6th, or, 1 million. Okay, great. So, although table R isn't so big, nor is table S, cross multiplications are really expensive for this reason. Okay, table R has 1,000, table S has 1,000, but when you create table R times S, there's 1,000,000 rows. And if you had another table, I don't know, T, that also had 1,000, and you you're cross multiplying all of these, this blows up to 1,000,000,000, right? 3 tables, each with 1,000 long, but when you do this cross multiplication, you need to compute a table with 1,000,000,000 rows. So that's expensive. Okay, that's the point of this. So cross multiplications are expensive. Actually, I'll keep those there. So the benefit of this is that there's no cross multiplications. This inner query, if the table had 1,000 rows, well, then this would return at most 1,000 entries. Here as well, you're just checking each SID whether or not it's in this list. So you can avoid cross multiplications. That's one reason to do nested queries. So avoids cross multiplication. That's the question. That would be the answer. Okay. Strictly speaking, the computational time isn't going to be so different. I'm not going to go into that, but if you're looking at it purely algorithmically, the time won't necessarily be different. But in the real world, this is actually creating this from, right? It is creating this gigantic table, this cross multiplication table, which means at the very least you need the space to do that. So it takes time to construct the table. The table, while you're using it, takes up space. And in this case, I'll get rid of the T here. At most, this query is going to return everybody, right? Every single sailor rented boat 103. So the number of results will be 1,000. Yet, in order to obtain that 1,000, you had to sidestep and create a table with 1,000,000 rows. I mean, you're eliminating 999,000 rows. that are trash, right? Like these are pairs that are meaningless, and you'll throw them out because of this. The SID and RID are going to be different. The vast majority of them are going to be different. So of this table with 1,000,000 rows, the best, you're going to be keeping at most 1,000. So that seems sort of like a waste. That being said, it depends on what the sizes of these tables are and stuff like that. But trying to avoid cross multiplication when possible is advised. Okay. Any questions about that? No? Okay. Just out of curiosity, how many people have seen a nested query before? I'm just curious, like if there's people who have seen this before this class. Partially remember it. Okay. Yeah. Okay. So this is a case where, okay, very good. Yeah, this is a case where it's preferred, maybe, to use a nested query, but it's not required. I mean, there is another query that you can run and it will return the same result, whatever. There's other cases where, as far as I can tell, it's required. And I'd like to give one example of that, and then also wrap up pretty much anything I'm going to be saying about SQL, as far as the syntax that's available to you. Okay. Yeah, so we've already talked about the where and all of the different things that can make up the predicate. But there's also here, you can add, or there's aggregations. The aggregations, so let me turn off my video. Okay, so the aggregations are max, min, average, sum. Oh, and I guess there's also count. Okay, so an aggregation is an operation that you do on every single element of the set. So if you have a set with a bunch of things, an aggregate operation means that you must visit every single member of the set in order to guarantee that you can compute whatever. For the sum, that's pretty obvious. If you wanted to compute the sum of each of these, well, you have to take that, plus that, plus that, plus that, plus that, plus all of them, right? You need to add them all together. And then only once you have looked at every single one of them and put them in your sum and sum them together can you actually compute the sum, for example. The average, basically the same thing, compute the sum and also keep track of how many elements are in the set. If you wanted to compute the max or the min, you can't be sure that you've found the max or min without having seen every single element, because there might be one that's smaller or bigger, respectively. Counting is the same thing. If you want to count, you need to look at each one and see how many there are. So, as an example, given relation sailors, same thing, they have an SID, they have a name, they have a rating, and they have an age. So given this, return the name of the oldest sailor. Okay. So if we view this as all of our sailors, these are all of our sailors, we want to return the name of the oldest one. So we're going to use nested queries here. The first to return what the age is, whatever the maximum age is, because we want the oldest one. So we need to figure out what the biggest age is. And once we know what that number is, then we can return the name of the person who has that number. So I'll do that kind of in that order. First of all, we're going to be referring to the Saylor's relation. That's the only one that we have, where s.age equals, and now we can do a select max s2.age from Saylor's as s2. And again, you don't need this, but I'm going to put it anyway. Where true. Okay, and then we're going to return the name of this. Okay, so again, this is getting whatever the maximum number is for the age, because we want the oldest one, so we need to know what his age is. And then we're going to be returning the name of the sailor whose age is equal to that maximum. So this is a case where, well, I guess you don't have to use nested queries here. You could just do more cross multiplications and multiply something with itself and all of this. But yeah, this is a cleaner way of doing it, I guess, in my opinion. I don't know, maybe as for fun, you can think about how you would do this without nested queries. But yeah, this is another example of them. And I think that, oh, and by the way, yeah, so this select, the aggregate option happens here in the SQL select statement. So these would not go in the from or the where. These go with the select. And of course, these need to be applied to, except for count, things that have some sort of ordering to them. For a maximum and an average sum, I mean, these have to be either numbers or could be spellings, except for the sum and average. But you could compute whatever. Okay. So I think that does it for SQL. Oh, no. I'm sorry, it doesn't. It doesn't. But we have enough time to finish this. It won't take long. Okay. First, we've talked about creating relations. We have to talk about inserting an entry, deleting an entry, deleting a table, and modifying a table. And also queries. This discussed above. Right, so this is what we've been mainly focusing on is the query part of it, and I think I'm done with that. But yeah, for the sake of completeness, we should do these others. So if you want to create a relation, then that is done like this. And I don't know, just for fun, I'll create a different table name. Create table, I'll call it students, whatever. Okay, and they're going to have a student ID that is going to be an integer. They're going to have a name that is going to be a character. By the way, strings are like this, character arrays. So here the name would be restricted to having 20 characters to it. Age, we'll call that an integer. We'll also give them a GPA that will be a real number. So that's a floating point, because people can have 2.4 where their age, I just want their age in years, not some real number. Okay. Tables have to have at least a primary key. In this case, it's going to be SID. Now, if you have a relation like, we talked about having composite keys. You could have each of these be a composite key. If it were a composite key like this, then the way that that's done is you just add both of the keys to the primary. It could also be the case that you have something like this. You want both the SID to be unique and you want the S name to be unique. In this case, SQL only supports using this phrase, primary key, one time. So in order to do this, you can use the unique word. And here, basically, the primary key and the unique work in the same way. But this would be the way to do when you want both of the columns to be unique. And you can use unique as many times as you like. Oh, shoot. Well, I might not be able to finish everything here, but because I also want to talk about foreign keys, but okay. That's a way of sort of making a table. Inserting an entry, it uses this, insert into, and then you reference the table that you want. And specify the values that you want to give to each of these. It's an example of how to insert. Deleting an entry. It's pretty straightforward as well. Delete from, and then the name of the table. For example, deleting a table is easy, but it's also something that you should maybe avoid a little bit. Just, I don't know, usually you'd rather modify a table to know that it's no longer in use, but still keep it in case you might have to reference it later. Where if you just delete the table, then it's gone, and you won't be able to do that. Table. So what's this? You can add columns, for example. And queries, yeah, discussed above. There's only, so this basically does it. The only thing that I have left to talk about is foreign keys, but I don't want to keep you, after class. So I'll start off the next lecture with that. It's fairly short. It'll take maybe 3 or 4 minutes. And after that, that's basically it for how to work with SQL. Oh, can I scroll up slightly? Yes. Not sure where exactly you want me to stop. Okay, so yeah, guys, that's it. You can log off if you like. I'll hang around if you guys have any questions about anything or whatever. Otherwise, I'll see you on Friday.